Okay, today what we're going to be talking about are common factors. First off, what are common factors? Common factors are of two numbers. We're going to look at two numbers, and common factors of two numbers are all the numbers that are factors of both. So let's do an example of this. Find the common factors of 12 and 30. Okay, so first off, what we need to do in this case is we need to find the factors of 12. Well, if you recall back a few sections ago, we learned how to find the factors of a number. Okay, what are the factors of 12? Well, to find the factors of 12, first start off with 1 and the number itself. 1 multiplied by 12 gives you 12. Okay, so 1 and 12 are both factors of 12. How about anything else? What's next? Well, look at the number that comes after 1. After 1 comes 2. Is 2 a factor of 12? 2 multiplied by a number gives you 12? Absolutely, 2 multiplied by 6. Okay, how about next? After 2 is 3. So you go 3 times 4, definitely. 3 times 4 gives you 12. And you're done with your list here. The way you know that is because if you went to the next number in your list on the left-hand side of the list, you'd come to 4. And 4 times 3 would give you 12. But haven't you already had those two numbers in your list? Absolutely. So you need not have them in the list anymore. You've already covered them in the list above. So what we have here for the factors of 12 are we have 1, 2, 3, 4, 6, and 12. So you make the list of factors, even though you utilize the factor pair idea to get the factors of those numbers, really the factors are just a list of numbers like that. Okay? So now let's look at the factors for 30. The factors for 30 are definitely start off with 1 and the number itself. Okay? Now go to the next number. What's 2? 2. Is 2 a factor of 30? Well, since 2 is even, yes, 2 is a factor of 30. So 2 multiplied by 15 will give you 30. Okay, how about the next number after 2? 3. Is 3 a factor of 30? And 3 multiplied by 10 is definitely two factors of 30. So what's next? 4. Is 4 a factor of 30? No, 4 is not, but 5 is. 5 multiplied by 6 gives you 30. And if you went to the next set of numbers after 5, it'd be 6 times 5, and those two numbers are already in your list, so you don't need to repeat them. Okay, so let's look here. The factors of 30 are 1, 2, 3, 5, 6, 10, 15, and finally 30. So there's our list of factors. Okay, now what we need to find are the common factors for both numbers. What is common between both lists? Well, looking here you see, oh, they both have a 1 in their list, so circle that. They also both have a 2 in their list and a 3. Anything else? Well, yeah, they have a 6 in common as well. So those are all the common factors of 12 and 30. 1, 2, 3, and 6 are all common factors. Okay, but what we're going to be talking about in this section is something called the greatest common factor. So the greatest common factor, or otherwise known as GCF, you'll see it abbreviated into GCF much of the rest of the chapters and throughout the rest of the book. Okay, what the GCF is the largest common factor of both numbers. So what's the largest common factor? The largest common factor is 6. Okay, so GCF of 12 and 30 is 6. There we go. Okay, so that's what we're looking for. We're looking for the largest factor that's common to both of those numbers. Okay, so what I want to do now is let's look over the prime factorization method for finding the GCF. So what's the prime factorization method? Well, that's another method that we're going to go through. We just went through finding the list of factors. Okay, but let's go through and find the greatest common factor using prime factorization. So doing this, first off, we're going to use the, let's write this here. We're going to use factor trees, something called factor trees. We've used those before. So factor trees, let's get the prime factorization of 12. Well, when we did that, we wrote it like this, and we said, what two numbers multiply together to give us 12? So what two numbers do? How about 2 and 6? That definitely works. So it doesn't matter how you start, what two numbers you use. You could use 3 times 4. Okay? Either way, you'll come to it. What we do here now is we circle the prime number. If one of those numbers is primes, we circle it. That will indicate that we're stopping that branch of the tree. Okay, how about 6? 6, what two numbers multiply together to give you 6? Well, 2 and 3. Okay, so each of those are prime numbers. Okay, so what we have here is we have that 12 is equal to 2 multiplied by 2 multiplied by 3. And that is what it means to be a prime factorization. You're getting all the factors of 12 that are prime numbers. Okay, how about 30? Okay, let's look at 30. How about 5 multiplied by 6? Okay, well, are either one of those prime? Well, 5 is. Okay, and so now you look and you go, okay, 6. What two numbers multiply together to give you 6? 2 times 3. And so you can circle that. Now again, it didn't matter how I started off with the first two numbers that multiply together to give you 30. You could use 3 and 10. Okay, it doesn't matter. You're going to wind up with the same prime factorization as me. It doesn't matter how you start. So here we have 30. 30 is equal to, and I always do it in lowest number to highest number, so there's some kind of an order when I write out my prime factorization. So I've got 2 times 3 times 5. Okay, so now what I'm looking for here is I'm looking for the greatest common factor. The way I find my greatest common factor here is I'm going to look for numbers that are both factors of 12 and 30 in their list of prime factorization, in their prime factorization list. So here, 12 and 30 both have a 2. So I'm going to write a 2 down in my GCF, in the line for the GCF. Now, is there anything else coming between those two numbers? If there is, you're going to multiply it by the 2. And in fact, there is. They both have a 3 in common. Okay, so you're going to have 3 here. So the GCF in this case is 2 times 3, which is 6. And if you look back to the previous page, 6 was the GCF of those two numbers. We just did it in another method. Okay? So let's find the GCF of 12 and 24. So now that we've got our prime factorization method down, let's use that. Okay, so 18. What two numbers multiply together to give you 18? Well, you could use 2 and 9. Okay, and noting that 2 is a prime number. Now 9 is 3 times 3. Okay, so 18 is equal to 2 times 3 times 3. So that's your goal, to write down the prime factorization of each of these numbers. How about 24? Well, of 24, we have many, many ways of getting 24. What two numbers multiply together to give you 24? Well, usually when I say that, I go, oh, how about 3 times 8? Again, it doesn't matter how you start. You could have started a different road. Okay, so 3 is a prime number. So how about 8? 8 is 2 multiplied by 4, where 2 is a prime number. 4 is not yet prime, so we got to keep going. Two numbers that multiply is 2 times 2. So again, circling those, noting that that's ending your branch and you don't need to continue factoring anymore. So what is 24? 24 is equal to 2 times 2 times 2 times 3. Okay, so now let's go through and get our GCF. So what is our GCF? Well, our GCF equals, again, you're looking for common numbers to both lists. They each have a 2 and they each have a 3. And if you look at the values that are left over, none of them are common between the lists. So in this case, GCF is 6, just like in the example above. Okay, but let's do another one. Let's do 40 and 60. Find the GCF of 40 and 60. So let's do the prime factorization of each. So 40, we could definitely say 5 times 8, okay, where 5 is a prime factor, or a prime number. So 8 is 2 times 4, and 4 is 2 times 2. Okay, so there's our prime factorization. Prime factorization of 40, again, writing the numbers in numerical, in lowest order, lowest number to highest number, a lot easier to keep track of the order of them. 2 times 2 times 2 times 5. And also, I don't use powers. I don't put 2 to the 3rd power. It's a lot harder to find the GCF when you put up using powers, so don't use the powers in this case either. Okay, so there's our prime factorization of 40. How about 60? 60 might be, how about 2 times 30? You could do it that way, right? Many, many ways to do it. My way is not necessarily the only way, okay? So make sure you investigate that. Try different numbers for 60. Okay, now with 30, what two numbers multiply together to give you 30? Well, we do 5 times 6, where 5 is a prime factor, and we have 2 and 3 for 6. Okay, so what's the prime factorization of 60? 60 is equal to 2 times 2 times 3 times 5. Okay, so now the big question, what is the GCF? Okay, so again, circling common numbers. Each of them have a 2 in common, so write that down. Only one time. It's whatever's common. Okay, now anything else common? They each have a 5, so it's 2 times 5. So the GCF is 10. Okay, so let's go on to the next example. Find the GCF of 25 and 26. Okay, 25. Let's go here. What two numbers multiply together to give you 25? Well, 5 and 5. It's the only way to go. Okay, there are no choices in this case. So 25 is equal to 5 multiplied by 5. Okay, so how about 26? What is 26? Well, this is 2 multiplied by 13. Okay, so write that down. 26 is equal to 2 multiplied by 13. Okay, do you see anything common between those two sets of numbers? Looking at the factors, the prime factorization, there's no numbers in common to each. But is it the case that I could say 25 is the same as 5 times 5 times 1? Well, absolutely. You know, 1 doesn't change the value of 5 times 5. 5 times 5 is 25. 25 times 1 is still 25. So there's always this hidden factor of 1 in any prime factorization that you write out. So if I put it that way, what is the GCF then? The GCF is 1. If there are no common factors in your prime factorization list, your GCF will always be 1. What this is called is relatively prime. To be relatively prime, two numbers are relatively prime if the numbers have no prime factors in common. So then your GCF is 1, as we said, as I showed you above in the previous example. Okay, so let's find the GCF, and you try it number 3. GCF of 6 and 14. Okay, 6 is 2 times 3. Now, each of those are prime, so we're done. That's all we had to do. So 6 is equal to 2 times 3. How about 14? 14 is 2 times 7. Each of those being prime. So 14 is equal to 2 times 7. So what's our GCF? Well, what numbers are common between the prime factorization of 6 and the prime factorization of 14? I see a 2. Okay, great. So now let's move on to 12 and 25. Okay, 12 is 3 times 4, where 3 is a prime number. Okay, 4 is 2 times 2. That ends all the branches. We need not go any further. So 12 is equal to 2 times 2 times 3. Okay, let's look at 25 now. We did 25 above, right? That was 5 times 5. Okay, so 25 was 5 times 5. Okay, so what's the GCF of 12 and 24? Are there any common factors with their within the prime factorizations? No, there are no prime factors in common, so the GCF is equal to 1. Okay, so that's how you would do that's what would happen if you had two numbers that had nothing in common. You could say that, and the other common is that those two numbers are relatively prime to each other. Okay, so let's look at the division method. Okay, the division method is just another way of going about finding the GCF. Okay, so in the division method, what we're going to do is we're going to have like an upside down division bar, and we're going to put 20 and 28 in here. What you're looking for are what's a common factor to both 20 and 28? It doesn't have to be prime. That's what's awesome about this method. Okay, because you can pull out anything that's common. You look at 20 and 28 and you go, I see that there's a 4 in common to each. And so you do that. You go, okay, 4. Let's divide 4 out. So what is 4 divided by 20? Well, or 20 divided by 4 is 5. And how about 28? 28 divided by 4 is 7. So what you have here is the greatest common factor is what sits out in front. What did you pull out of both of those numbers? What did you factor out? So GCF in this case is 4. Great. Okay, so let's move on to the next example. You try it, number 4C. 36 and 54. Okay, when you look at those two numbers, look at them and go, what two numbers do I see in common there? Well, in 36 and in 54, I know that there's a 6 in each. Okay, so divide 6 out of each of those numbers. Well, 36 divided by 6 is 6, and 54 divided by 6 is 9. Okay, now you have to look and say, I wrote a little quickly there, but what you have to do is you have to look at those two numbers, 6 and 9, that are left over, and you go, are there any common factors within 6 and 9? And if there are, you have to continue. You continue until you can't pull any other factors out or factor anything else out. Okay, between 6 and 9, there's a 3 in each of those, leaving us with a 2 here and a 3 here when dividing it out. Do you notice now within 2 and 3, you can't divide any other numbers out. There's nothing else in common. Okay, so what is your GCF? Your GCF is the product of whatever sits out in front. Whatever you've pulled out of those numbers, that's the GCF. So the GCF is equal to 6 times 3, which is 18. Okay, so that's how you go about doing that. Okay, so let me circle that answer there for you. Okay, so find the GCF of 270 and 520. So a lot larger numbers now. So let's try this one out. Let's see what we can do here. Okay, so we can use either method for this. Okay, it doesn't have to be the division method or the prime factorization method. You might have attached to one of them better than the other. So use what you're comfortable with. Okay, I'm going to use the division method on this. I'm going to go 270 and 520. Factor out whatever is common. Well, what is common between those two numbers? Well, since they both end in a 0, you could definitely factor out a 10. So let's do this. 27 and 52 are what are left over if you divide that out. Okay, so how about in 27 and 52? Let's look at let's look at 27. 27 has a 3 involved, right? There's 3 times 3 times 3 gives you 27. So there's only 3s in 27. If you look at 52, you go, well, if I can only divide 3 out of 27, then I need to divide 3 out of 52. Is there a 3 involved with 52? Well, if you use your divisibility test, if you remember that, for 3, you add the digits together, 5 plus 2. 5 plus 2 is 7. 3 does not divide into a number that have the digits adding to 7. Okay, so you're done. Your GCF here is 10. Okay, so that was nice and quick. All you had to do was factor out the 10, and that was it. You were done. Okay, let's look at what happens if you did it the prime factorization route. Okay, we can do this method over here. Okay, so if you look at 270 and 520, you could go 10 times 27, and 10 is 2 times 5, ending that branch. 27 was 3 times 9. 3 is prime, and so now 9 is 3 times 3. And so that gives you the prime factorization for 270 is 2 multiplied by 3 times 3 times 3 times 5. Okay, so now we have to do 520. Always definitely look for that 0 at the end because it makes life a lot easier to be able to say, oh, this is 10 times 52. It makes it much more easy numbers to deal with when they're numbers less than 100. Okay, so 10 is 2 and 5. Oh, okay, there we go. How about 52? 52, what number goes into 52? Well, how about we have 2 multiplied by 26, right? So 2 is prime. How about 26? Well, the reason why I picked 2 above is because I knew 52 was even, and I thought, okay, well, I don't have to think so hard there. If I know that a number is even, 2 will always be a factor of it, so then I just divided 52 in half. Okay, how about 26? Well, 26 again is even, and so I put a 2 there, that being prime. Well, what's 26 divided by 2 is 13. Okay, so now for 520, what this is equal to is 2 times 2 times 2 times 5 times 13. Okay, so what's the GCF? The GCF is whatever numbers are common to both. Let's look for those. There's a 2 in each, and there's a 5 in each, which gives us 2 times 5, and that gives us out a value of 10. Okay, so what does that tell us? See, look at the work you had to do between each of them. There's a lot more work going on in prime factorization, but if you understand it, stick with it. Okay, so that's how you do those division method and prime factorization method to find the GCF. Good luck with the section, and I'll see you next time.